Hi guys, I have an amplifier here. This is off a powered speaker. It has an Alpha -A. I mean, that's the only marking on it. It doesn't seem to have any other brand on this, unless I just can't see it. That's what's actually inside it. Okay, this is how it's come to me. And the guy says this is urgent. I was working on another job, and he said, and it was for the same guy, by the way, and he said, this is urgent, put that down and look at this one. So there we go. The first thing I'll mention about this has these mains input sockets, 220 volt or 115 volt, you can see here, with the fuse, power switch, AC input and link. So this is an AC output, okay? Now, these connectors, although they look rather like a speak-on connector, if you know the amplifier audio out, these have 3 poles in them. So you have like the live, neutral, and earth, or tierra, as they call it in Spanish. He just told me today. And although they physically look like a speak-on connector, they are not actually the same. So these are called PowerCon. Now, they had up to 20 amps. I had one of these on the big rack mounting cabinet I had all my amplifiers in when I had the last mobile disco in the UK, 19-inch rack. But I don't have that plug lead anymore, and I don't have one. So if you're wondering what these are, you can see here, 3-pin PowerCon connector. Okay, this is the one. They have blue and they have the grey for the out, and they're not the same. Okay, you can't put like a grey plug into a blue socket. And I can get 5 of these for €2, so I've put them in the cart. They're ready to order. Okay, they'll turn up. But that's not for today. So I need to figure out how to get some power into this to test it. From what I understood, it kind of went boom, boom, boom or something. He says that's about the best way he described it in Spanish. But usually I'll just have a look myself and see what's happening with it. What I do know, in fact he pointed it out to me, is that this is burnt up. Okay, this resistor is burnt. Because I don't know what brand this is, I can't really find a schematic, or maybe I can. So this says A-amp 2 PCB. I'll Google that, you never know how lucky I might be. This has a big transformer on here, so we can see 0115, 0115, black, red, blue, purple. So we can see that the primary of the transformer is here. Yeah, it says black, red, blue, purple. So these big thick ones here are actually the primary. This is one of the secondaries, these other blue ones. And if we follow these along, you can see they all go down here. Okay, and this is the main selector switch. So this will put them, I suspect, in parallel or in series, or just use one winding or both. I haven't looked, to be quite honest. And then coming back out of here, we have some red wires. I've cut off the cable ties on here, by the way, the zip ties, so I can get to this. So we can see these red wires come out of here, and these go down here to this board. Okay, so this is where the power comes into the transformer on these two. And if we measure across here, for start with, we should be able to measure the transformer primary. Of course, I don't know what it should measure, but let's have a look. At least it should measure something. It shouldn't be open. I'll just get across here. That's reading 3 ohms. That's fairly low, but it's a high-powered transformer. I honestly don't know what it should measure, is the truth of it. And that comes through here, so you can see these are the NTC thermistors. 2 of them, probably in parallel. So from here now we're measuring the resistance of the primary via the NTCs. About 18 ohms, 17 ohms, 16. This relay, by the way, this will be wired across the NTCs so that the current comes in, voltage comes up, and then somewhere on the circuit, it then switches this relay on to short these out. So effectively the resistance of these is now 0. You find that quite a lot on high powered amplifiers. So these input wires, if we have a look, these go down to the power switch here. Okay. So that's effectively where the power's coming in. So there's also a fuse in the circuit down here as well. I've tested the fuse is okay. So to test this, because I don't have the proper power con plug, I'm actually going to put some mains power on here via my current limiting light bulb. Later I could actually wire a fuse in line with that if I really want. So just for now I'm actually bypassing the power switch and the fuse. But I will just prove they're okay. So we know this is the connection to the transformer, one of them. Primary. If I go to this power con connector here, I should find a connection somewhere. Okay. Yeah, there's a connection to there. Okay. And there should be a connection to here. What should reach 12 ohms? Yeah, the reason that reads 13 ohms is because I'm coming through the two thermistors and I know they measure about 13 ohms. Yeah. There. Okay. So I know I've got a connection through to here. Everything reads okay. This reads okay. I'm going to connect power leads onto here so I can actually power this up. I'm going to put the light bulb on to see what happens. But before I do that, I want to just have a look around this burnt up resistor and see if I can see any shorts or something on here that may have caused that to happen. Okay. The resistors, I'll just go to ohms range actually. Resistors are low value. I think they're 10 ohm actually. No, they're less than that. 10. It's marked like a 10 ohm resistor, this one is. But reads short. This one is obviously gone, but we know that. Let me see first if I can actually find any schematic for this. And if not, we'll have to have a look around. I'm pretty sure something is short on here. So a-amp2.pcb. I've had a look, but that number didn't help me. I thought maybe also this was alpha. So I tried that model number with alpha rather than A, still didn't help. I spoke to the guy who brought me this in, asked him if he knows the make and model number of the amplified speaker this came from, and he doesn't. So he told me it's a full range cabinet, so I'm guessing this must have a passive crossover because we can see here that his output on here looks like the only output, so it must go into the crossover. By the looks of it, this is not like a bi-amp speaker or something like that. It's difficult to see down here exactly what I have. Obviously a lot of power devices here. I can just about see down there. And there are a lot of devices. So this must be class A, B or G or something amplifier. This is not a class D, because I think it was fairly obvious anyway. Let's see, can we get this top cover off? I want to see if I actually get a bit into that to see what I actually have. Okay, I've basically got the amplifier module off here now. So I can actually get to both sides of this. I've taken that metal panel off and then I just release this from the front panel. So this is the actual amplifier module, this thing, okay. Let's have a look. So on this side we've got 4, 10, NPN. I know because he is C, so 2SC is NPN, 2SA is PNP. So we've got 10 NPN devices. That's a double diode. This is an NPN transistor and this is an NPN transistor. So probably the drivers. Yeah, C4793 and the one at the end is the same. Right, so let's have a look at what we've got. So red to the base, black to the collector, that reads a diode junction. That reads low, but that will be the base emitter resistor. I'm pretty sure just going to ohms range. You'd expect these to have a low value base emitter resistor, 55 ohms, okay. So that's going to affect the reading in diode mode. And then collector positive with respect to the emitter should read open. And it doesn't. So in normal operation, the collector would be positive with respect to the emitter. And I wouldn't really expect to read anything. I mean, it's climbing up, but that pretty much tells me there's something wrong somewhere. How I will actually go. Is this a capacitor charge? I'm a bit suspicious of that. I would expect to read basically open in this polarity. Okay. So next one, diode junction, low reading, and then that again. Are these in parallel? I bet they are. Yeah, they're all in parallel. But those two and these two are not in parallel with each other. Okay. Didn't really expect that, but that's what I have. What else do we have? So this looks like a driver. Yeah, diode junction. Diode junction. That odd reading again. Looks like another driver. Diode junction. Diode junction. Odd reading. How about these ones? Are these in parallel as well? They're not in parallel with those, and they're not in parallel with those. They're in parallel with each other? No. Oh, that one and that one and that one are in parallel with each other. And then, is it this one? This one. And this one are in parallel with each other. But they're not in parallel, again, one set to the other set. And then this double diode, this is a common anode, you can see, so the red to here. Diode. Diode. Okay, these don't have the emitter resistor either. So we can read the base collector, base emitter. Yeah. Oh, base of that one goes to the emitter of that one. This is a strange configuration, look. I can't just get my head around how these are wired up at the moment. Schematic would be rather helpful. But they test okay. Do I have that odd reading? Yeah, positive to the collector again. I have this odd reading. On those. Yeah, and on there as well. The reason I think that's odd is because I'm in the same polarity that you'd expect the device to be used in circuit. And I wouldn't expect to see that's reading like 2 volts. So it's almost like saying the voltage here can't go any higher than that. Yeah. So we're going to do the side of this amplifier. And I'm guessing we have a lot of PNP transistors. And it looks like we do have. So the same thing but complementary by the looks of it. This driver, assuming this is the pin out, will now be PNP, so it won't read in that direction. I did get a reading that way. How about this way? Diode junction. I mean, that one reads both ways, like there's something across it, okay, but it's not short. This one, basically the same. Again, with the negative to the collector, which I think it is. I see that funny reading. This is the diode, so the diode on this is the opposite way around. Actually reads in the reverse direction. So does that. This is the direction that you'd expect it to be working. Strange. Well, that doesn't look right. This is the cathode, so that should read to there and doesn't. But if I go to the wrong polarity for the diode, that reads, no, it's not a diode. So this is faulty. That's the first thing we can say. Okay. And then these ones, so what do we have here? So again, the PNP. And again, they don't have the emitter resistors like we found on the other side. These are in parallel. Those two are not, but these two are. Strange. These are in parallel. Notice there's like 1 and then 2. That's how it looks to me. Parallel. Not. Yeah. So it was like those two are in parallel being driven by this one, and these two are in parallel being driven by that one. It's starting to make a bit more sense now. So if I go, just check these diode junctions, looks okay, looks okay, looks okay, yeah, looks okay, looks okay, alright. If I now go with the negative to the collector, because this is the way it would normally be in circuit, that reads this funny reading again. This also, I think, explains why the base of one seems to go to the emitter of the other, because one's driving the other. On the other side, remember that funny reading I got? I wondered why. Yeah, there. So the emitter of this one is driving the base of this one. and that one. Okay, yeah, that makes some sense now. And then the same on this side. So you emitter of here, driving base of this one, and base of this one. I'm making some sense of this now, guys. Hope you're following. And then back just to the other side once again. Which was the driver, this one. Emitter of this one. Drives the base of these ones. Yeah. And then the emitter of this one, I think. Was it, maybe it's this one, I'll just find the right one. Yeah. Drives the base of those two. So we basically know what we have, and we know we have a faulty diode. This one reads good. This one reads bad. Okay. Well, I ain't got those, so this isn't going to get fixed urgently. That's the first thing. That's the first problem. Now, why is this resistor burned up? And why am I seeing these funny readings that I don't like? Well, that diode, I'm sure, is involved in the circuit that switches the supply voltage. So this is a class G amplifier. That basically means that the output devices, these four, are supplied by one of two voltages. Normally it's like 45 or 90 on a lot of amplifiers, okay? And these ones are effectively switching that voltage, and the other one is driving the pair, whichever way around. I think these were the drivers and these were the output ones, and that's why this diode is here, so that effectively the higher voltage, the 90, doesn't short to the lower voltage, okay? That's what that's for. So that would say that we would have multiple outputs on the transformer. So let's see what we do have. We know about the power coming in. Yeah, well, we know about that. We have 4 times 23 volt. 1, 2, 3, there's 5 colours by the looks of it here. Oh, black is the centre tap, okay. So it looks like we have 23 volt, 23 volt, centre tap, 23, 23. But I'll bet in actual fact, what we really have is black, 2346, 2346. So the yellow and the lower voltage supply to the amplifier via those funny transistors we had and diodes, and then the reds are the high. So this is like LT and HT. And we have plus or minus 23 and plus or minus 46. So a lower voltage than I expected. So this is actually a lower powered amplifier than I thought. We have a couple of 7 volt outputs. Probably generates a plus and minus 5. And then we have a couple of 18.5. So these blue, black and blue will generate a plus and minus 15 through a regulator. And then there's a fuse, which is the red wire. So the red wires on here go via the fuse. And the fuse is kind of like not on the input to the transformer, but kind of like in the middle of it somewhere. Okay. Say middle, I mean somewhere in between the windings. It'll be in the primary. So what we probably have, this is a guess, is we have the first primary winding, 115 volts between the black and red, and then we go to the other red, which comes out to the fuse, back in on this red, and then we have blue, purple, okay, which is the other winding. That's how I think it will be. We know the fuse is okay. I don't appear to have any shorts in the output devices on the transistors. I don't see any shorts over there. I do see some readings I'm not very happy with. There are the 2 resistors. Now this reads like it should be 10 ohm. So brown is 1, black is 0, and 0 more zeros, 10 ohms. And that should be 10 ohms. I'm only guessing that's 10 ohm as well. I mean, there's another one here. We have, oh look, low voltage to the collectors, yeah. Low voltage collectors. So this will be the positive low voltage, there's the minus low voltage loop coming from the transformer via some circuit board down here which has capacitors and things on it. Yeah, this will have the bridge rectifiers and such like, I would think. We have those, and then we see HV, high voltage to collectors, okay, and there'll be a negative, that's the positive one, so there'll be a minus HV somewhere, yeah, minus HV to the collectors. Okay, so a bit of a poke around there, guys, but we know what we have, and the fault seems to be in the switching between the high and low voltage on the negative side of the amplifier. Okay, while we were just doing that, by the way, the guy actually replied again. So this is what the amplifier comes from. I don't know if there's only one or more of the amplifiers on here. It comes from this line array, Biema or Iris. This thing, look, pictures there. So this is what we're actually dealing with here. Okay, amplifier is off this. Maybe now I can find a schematic. Yeah, he tells me it's the Biema Alpha A. That's what I actually have. Yeah, so I've actually found the link to this now. So this amplifier module is out of one of these. Okay, line array loudspeaker designed to give the best audio quality. Ideal for applications require big power, medium to short throw distance. Okay. Yeah, tells you here about they all sort of stacked together basically, quick rigging. So that gives us some idea. So it's actually a 400 watt amplifier. That kind of goes along with what I said. It's not overly powerful, this one, I don't think. So yeah, that's what these things actually are. This is what they will put on these big carrozas, which are what you would call floats, okay? Yep, there. So this comes off some pretty impressive kit. Unfortunately, what I don't seem to have is a schematic for this, so we're kind of a bit on our own with this one at the moment, unless you know otherwise. Let's see how much further I can get with this without a schematic. Because I see some strange readings here, this may be responsible for those funny readings I've been seeing around the amplifier elsewhere. Similar sort of reading. So let's take that out, see what we find then with those other weird readings. Also, that being open circuit doesn't necessarily explain why this resistor is burnt up. I can see 1, 2, how many more of these things? 3. These are smaller ones. I see 3 of these. Well, 2 are marked at 10 ohms. Okay. I wouldn't be surprised if these were parallel with these inductors. Sometimes you see like resistors inside them. I don't know about that. Let's have a look. So this reads like a short. I think that might be connected to this. Looks like it. So that probably explains why that reads short. There's another one here that also reads short, but again it's next to this inductor, and it appears to be connected across it. Yeah, I think so. Yeah, but this one doesn't have an inductor by it, and because of that I have really no way I can say whether that is actually a 10 ohm resistor. It's not the same as these two, so why can we assume it's the same value? That's a problem. Okay. What's it reading? Well, it's reading about 6K, but I don't think that's what it's supposed to be. Let's take this diode out first. That's the first thing I'm interested in. It looks to me like this is being unsoldered before and they've just cut the legs rather than actually taking it out of the board and then solder the legs back on. Let's see. Now it looks more like that they've soldered a piece of wire to the leg. You see they've obviously done something here. This one the same. Okay. Looks like the same on this one. Okay, yeah, you can see it's coming through the board. Okay. Maybe this device, the legs were too short. Maybe it's been salvaged from somewhere and this is just to make a connection from a previous repair. That's another guess. Okay. It's coming out anyway. Yeah, I can see now. So this looks like it's being cut off another board and then these wires are effectively a repair. Okay. Yeah. So there it is. Now it doesn't read open. You saw before this was reading open. I wonder if the problem was in that soldering. Yeah, there's that funny reading. that's fun. So this then looks like effectively just somebody else's repair, a bit of a bodge job, failed. That may be why that resistor burns up. I'm just trying to figure out where this resistor actually is in the circuit, because I don't know what value it is. That is the real problem. So maybe he has another one of these and he can read it for me. I doubt it's a high value. It's reading 5k, and the reason for that, there's no like particularly high voltages in this. I mean, the highest effectively is, I suppose it could be 46 to ground or 46 to 46 plus or minus, but I don't see why you would have a resistor like that across the power rail or from a power rail to ground either. It doesn't really make a lot of sense. Where does this thing go? So first of all, where is ground? That's another good question. It looks like the speaker attaches here. Okay, between this coil and resistor, this coil and resistor, that's where the speaker goes, I think. Let's have a look. Yeah, I can clearly see actually, I don't even need to track it out. I can clearly see that the speaker goes to this end of this coil and this one goes to this end of this coil. No, oh, I bet this one goes via this relay. There's a relay here. So I'm sure actually that speaker connection is via this relay. And it does go to this coil, I would think. Makes sense. It's hard to say because the heatsink is in the way. I can't get to the back of here, not easily. But I have every good reason to believe as effectively this speaker connects via that relay to this coil. Yeah, it makes sense. So the protect circuit would effectively connect that if it thought everything was okay, otherwise it would switch it off. Right, so let's see if we can just clean this area up a little bit. Okay, I've had a bit of a look around this, just trying to figure out how this is wired up. Seems I was wrong again as I was trying to work this out, but you know, I have no schematics. What I can see is at this point out, this is for the speaker, and I'm sure it goes to the relay. I'm just sure of that. This is the other speaker out here, okay? And then we have these transistors. So I know I have like a driver and some output stages. And if I come from here, I find the two where the emitters are connected together. That one and that comes to here. Okay, so this speaker output we can see goes to the emitter of these two, but it doesn't go over to these ones. Okay, the ones over there. It also goes on this side, emitter. So that's connected between the junction of the emitters of these ones. Yeah, so that's where that's going. So this is actually being driven by this pair, and this pair looks like that then derives the base of these from the emitter of this one. Yeah. Okay, so those are like the output devices in actual fact, which surprised me a little bit. I would have thought they were these with all these emitter resistors on. Okay. This speaker out, the other one, where's that go? Well, it doesn't go off over here. I'm assuming it must go to ground. This point here. If I have to find out where ground is on this. Well, I'm not sure where the other end of this goes to. I would have thought if this end of the speaker is connecting between the emitters of the MPN and PNP, that's the output, then the other end of the speaker would go to ground. It probably goes via this relay somewhere. So we don't have a connection between the speaker output to here, to this coil. And this coil also doesn't seem to go to ground, which is there. It's the black lead. You can see it here. This comes all the way from the transformer. Center tap over here. So this is ground. So I can't really see where that gets its path to ground. I mean, I know we have the relay here, but I would have thought the relay either disconnects the speaker from this end of the coil or disconnects the coil from that end to ground. I can't imagine it would like disconnect both. 24 volt relay, by the way. That makes sense because we have 24 volt supplies, 4 of them. Okay. Without taking all these heat sinks off, I can't see where that is effectively going in the circuit. Yeah, that's interesting. So there's some mysteries here. I can't see the speaker path back to ground. I can't imagine anywhere else it goes unless this is like a bridge. But then you would have to have some output devices over here and they would kind of have to match that and they look different, if you see what I mean. But assuming that end of the coil doesn't go to ground, I have a connection on it. It doesn't go here either. Okay. Doesn't go to any of those devices. So I can only assume that this should go to ground. That brings us back to this resistor then. So if we look at it, the speaker out here, this speaker out, connects, you can see it goes under here, and it connects to this end of the resistor, okay? The other speaker out, which is here, connects to this end of this resistor, okay? The resistor is in parallel with the coil, as is that one. And this end of this resistor, or one end, let's have a look where this track goes. We have a capacitor here, okay? That capacitor connects to one end or the other of this resistor. Okay, I don't know which end because the coils across the resistor, so it reads like a short, but that end of that capacitor connects to that. And this end of the capacitor, same capacitor here, connects to that. And we know this connects to that. So I would say that this point here, one or the other ends of this capacitor are connecting maybe into this thing. Is this sensing the voltage on the output? Maybe this is what does the protection. What is this chip? C1237HA. Oh look, protector IC for stereo power amplifier. So that's exactly what that is doing. Okay, so I have the data sheet. We can see basically from this typical application that pin 2 is effectively an input. Pin 2. We also have pin 1 is effectively an input. So it's like a comparator between the two. Pin 1 just here says terminal for overload detection. Pin 2 shows it's connecting to the output of the amplifier. Now we have 2 channels here, okay? This is stereo. We are fairly sure we have one, but you know what? I'm not totally even sure of that now. But we can see the value of the resistor is fairly high, 56k. Let's have a look on our PCB again, see if we can make any sense of this. Here's, I'm assuming it's pin 2 which end up. I'm going to guess this end is the pin 2 over here, okay? And that goes, well, does it go here? No, it doesn't go there. Doesn't go there. We have some resistors here. Let's see. Goes to there. Oh, and there. And there. Goes to at least these 3. Okay, what about these ones over here? No. So pin 2 goes to these resistors. So any of these resistors go here. No. No, how about the other end? Yeah. So that goes to the end of this resistor. That looks like a 6.8K. Blue, grey, orange. It could be a 68K actually. The colour balance isn't very good on my camera, to be honest, guys. Yeah, it looks like a 68K resistor. This looks like another 68K resistor. It goes to both. But the end of that one doesn't go there. So I go to ground. No. Okay, I've solved a bit more of the puzzle. So I can see that the middle junction of here, this is low voltage collectors, negative. Goes to the junction of the diodes, okay? And then this end goes to the collectors of these ones. And the other input to this diode, which is here, it doesn't come from high voltage collectors. The emitters of these ones comes back to there. So this, I'm pretty sure, is switching the high voltage here, or the low voltage is there, and that alters the voltage on this collector. And then we're going to have the same on the positive side. So on this end we have the low voltage coming in, positive, via the diode, this way round to here, okay, collectors. And then the other input on here, which is this one, doesn't go to the high voltage collectors plus, but it will go to these emitters of some of these. Yeah, there, that one and that one. So these are in fact doing the voltage switching, and then the HV collectors on here does go then to the collectors on some of these. Yeah, so that's definitely how this is working. These are doing the switching. This resistor and that one appear to be involved with the protect circuit, and it may well be that is the same value as that. I can find a connection from that into one of these resistors, but I can't find the connection from this one into it, and that's a bit puzzling. So again, I'm missing something a bit fundamental that may be able to tell me what value that resistor is supposed to be, but at this moment in time, apart from I've broken a chunk off it, it's hard to say. Now I have broken a chunk off it though. Let's just try something. So we go to ohms range. Let me just measure across part of the body of it. Forget a connection to it. So let's just, may as well break the rest of it off as well. Let's have a look. So from this end of the resistor, the pin, that means basically 0, 5K. So that's reading 0. I'll just zoom in a little bit, okay. Where you can see, so I'm here, I'm on the end of the leg, okay. And this end of the resistor, the metal cap, basically reads 4 ohms, okay. In fact, it's reading like a short now. And if I move along a little bit, it's now reading 5K. So I have an open circuit there, I think. Now let's go to this end of it. So from this end of the resistor, onto the body of it. That's reading basically open. I was hoping I'd see like a reading there. Yeah, that's reading 2 ohms. Can you see it? And if I come a bit further along it, it's reading 5. Now if we go to the middle, it's reading 4 or 5. So from there to there is 4 or 5. I come towards the end, it goes to 5k. Come a little bit further in, 5k, 6k. I'm looking for the point at which it loses the connection, basically. Here. About 7 ohms, about halfway. So that tells me that if half of this resistor is about 5 or 7 ohms, there's every likelihood that is another 10 ohm resistor. Because I'm measuring kind of half of the resistive track. In fact, you can see, can't you? There's like a spiral cut into it here, you see there? That reads 6k. This is where it's gone, I think. So from the end of here, well, that's saying about 9 ohms from this one here. 15, 16, 33. I'm trying to add the two halves together. I'm thinking it may be a bit more than a 10 ohm resistor. So the furthest I can see along here is about there somewhere. Try even to get a steady reading from it. 10 to there, okay? And then from the other end, as far as I can get down the track before it breaks, here somewhere, about 5. So maybe that's like about a 15 ohm resistor. That's the closest I can come up with, but I have one other possibility with this, and that is to speak to the owner. So I've actually already done that. I've messaged him and asked him if he has any more of these amplifiers, and if he does, will he open one up and have a look to tell me what value that component is. Okay? There's a little bit more we can go even further with this. So if we look at these resistors over here, these are 0.050, 5 watt, all of them, both sides, okay? And then these ones here are 0.2 ohm, yeah, 5 watt. Now, 0.2 ohms is basically the sort of value you would expect to have as the emitter resistors on an output of an amplifier. We can see that this diode switches the voltage onto these ones here and also onto these ones here, okay, and that also comes back to here as well and here as well. And we have 4 of these 0.2 ohm. That would explain why we have 2 of these circuits feeding into here, and it would explain why that one probably doesn't go to ground and it might go to the emitters of these. Yes. Yes. So if it goes to those ones, that's this pair here. Okay, assuming those are switching. So driver output. So if it goes to the outputs of those, which we know it does now, so emitter goes to here. The emitter of these must go there as well. Yes, it does. Okay, so that solves the mystery of the ground then. This is a bridge circuit. This end of the speaker is being driven by these pairs of transistors with a driver. This end of the speaker has been driven by this pair plus a driver, so that accounts for all of those. These switch the voltage, so the voltage on the alternate pairs can be 25 or whatever it is. Remember, that's the AC voltage, is probably a bit more, maybe 30 odd. So they can be 30 odd or they can be about 60, okay? And that's how it's working now. So we effectively have two bridged amplifiers, and this is the switching circuit. So at last, I figured out how this all connects up. This relay then just disconnects one end of the speaker from this side of the bridge. Fair enough. Those do match. So again, we still don't know exactly what the value of this resistor should be. And I'm a little bit concerned to figure out how this gets into that. Because I would expect to see from this end of the resistor coming into one of these resistors into here. And I don't see that. Unless it comes in on pin 1. Remember, that's the other input. Okay, pin 1 goes to this resistor. Does this go to here? No, I still don't have a connection to there. Possibly then that this pin 2 is just monitoring from here via that 56k resistor. A bit like the datasheet showed us. And it's also monitoring this output via the resistor and the capacitor, okay? Having said that, I'm a bit surprised that resistor burnt out if it's only connecting via a capacitor. But hey, unless we get this board off here to see what's on the other side, it's a little bit difficult, and I'm a little bit concerned that maybe something on the other side of here is also burnt, which is why we can't find a connection from there to there. I don't really want to have to take all this off if I don't have to, because it looks like a right real pain in the ass, what I may have to do. So I've asked the guy who brought me this in, does he have any more of these amplifiers? If he has another one, I've asked him to see what value this resistor is on the other one, okay? If he can't, then I'm going to have to put something like a 10 ohm resistor in here. We do know it's a fairly low value resistor at least, and see what happens. Unless you guys know what value that resistor should be. Yeah? If you do, let me know, and then we'll carry on with this. But I think we have a good chance of repairing this. I've solved all the mysteries now, really, I think, apart from that. Okay? Hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.